Hey guys, thanks for not bailing on the last video and rejoining me here. Uh, this last problem is a little different, so it is kind of important. You can just look at it and say this is different. It's not written as a single fraction. It's written as a fraction and then a constant part here. So before we actually get into this, uh, actually we'll do that later. Um, let's ignore the number part for a little bit, okay? And just kind of think about this. So vertical asymptote, well, it's still going to happen at x equals -1. My domain, well, -1 still messes it up, so it's still that. Okay, nothing really different. I'll throw down my vertical asymptote at -1. Okay, doesn't have a hole. There's no common factor in the numerator and denominator. How you figure out the asymptote is where it's going to get weird. Okay, so we'll come back to that. Zeros. Okay, so let's actually do some algebra here. I want to figure out when the y is going to be 0, so I'm trying to solve this equation. Be careful about how you solve this. Add the 2 over. Multiply the x plus 1 up. Cross multiply if you want to think about it like that. Alright, then subtract it over, you get -1. Divided by 2, you get -1/2. Okay, so just be a little careful. -1/2. 0 is my x-intercept. Y-intercept, I'm just going to plug in 0 for x. 1 over 1 is 1, minus 1, or minus 2 is -1. So 0, -1 is my y-intercept. Okay. Okay. So now if we think about the asymptote and the end behavior, the way to think about this is, let's just, in your mind, think about if you plugged in a super large number for x. Let's say you plugged in 1,000,000 for x. You'd have 1 divided by 1,000,001. Well, 1 divided by 1,000,001 is like 0, basically. It's really small. Minus 2. Something really small minus 2. Basically -2. Okay, so as you plug in very large x's, 1 divided by x plus 1 gets close to 0, and it doesn't really impact our y value, because 1 divided by 1,000,000 is basically 0. So what happens when you plug in really big numbers is this thing looks like -2. If you plug in really small numbers, like -10,000,000, same thing happens. Basically just -2. Not exactly -2, but it's close to -2. In other words, -2 is our asymptote. Okay, it's our horizontal asymptote. So this form is actually kind of written nicely because they kind of put this out there. It's kind of written to tell you what the asymptote is. Okay, and the other ones you have to kind of like do some work to figure out what the asymptote is. This one is kind of written out there like that. Helps with our end behavior as always. If you're not seeing that connection, make sure you're aware of that. Like the asymptote and the end behavior are very closely aligned. In this case, it's a horizontal asymptote. As x goes to infinity, well, it's going to get close to that green line. So my y is going to go to -2. Same thing with as I go to -infinity. Okay. I know what this chunk looks like. And then for this chunk, I hope you're getting a hang of this. It probably either looks like this or like this. Let me plug in -5 to see. You can always plug in more points if you're not sure what the shape looks like, but I'm pretty sure. You plug in -5. 1 divided by -4. -1/4 minus 2. -2 1/4. So at -5, I'm at -2 1/4. Yep, so it's down there. And I'm done. Okay? So Didn't really do any of the factoring. Different way to find that asymptote, but that's about it. It's different with this one. Okay? So you should be in good shape now to do the rational practice problems number 3. Go ahead and get going on that. Thanks.